All right, today we're going to unpack MLOps, or machine learning operations. You can think of it as this hidden engine that takes a brilliant model from a data scientist's laptop and actually makes it work reliably out in the complex, messy real world. So, yeah, let's pull back the curtain and see how this all really works. So, let's set the scene. You've done it. You've spent weeks, maybe months, training this incredible machine learning model. The accuracy? 99%. It's perfect. But then, you push it out into the real world and performance just tanks. Sound familiar? It's a classic, and let's be honest, super frustrating problem. And it's exactly the problem MLOps is built to solve. The reason it all falls apart is this huge gap between the lab and production. I mean, think about it. In the lab, everything is perfect, right? The data is clean, your environment is totally stable. Production, though, oh, that's a whole different beast. It's a chaotic symphony of messy, unpredictable data, serious resource constraints, and a world that just won't stop changing. Your model's performance, it's gonna drift. It's inevitable. And that is where MLOps comes into the picture. It's the bridge across that gap. It's so much more than just, pushing a model out the door. It's really about building this entire system, this framework that makes sure your model is reproducible, totally robust, and can actually adapt as the world changes around it. Okay, so to really get our heads around MLOps, we need a map, a blueprint. And for us, that map is the machine learning lifecycle. It's going to be our guide through every single step of a model's journey. Just take a look at this whole journey. You can see it's not just a straight line from A to B. It kicks off with defining the business problem, moves through all the data prep and feature engineering, and then gets into the fun stuff, model training and evaluation. But, and this is so important, it doesn't just stop at deployment. Look at those last two steps, monitoring and retraining. They create this continuous loop, because a model out there in the wild is basically a living thing. It needs constant care and feeding. And that right there really highlights the core challenge, doesn't it? The lab, that's the easy part. The real test, the real crucible, is deployment. That's where your model has to face the wild, totally unpredictable nature of real-world data. All right, so let's get into the nitty-gritty. The very first problem MLOps has to tackle is the sheer chaos of experimentation. I mean, how on earth do you keep track of hundreds of different model runs, each with its own unique set of parameters and results? It can be a nightmare. Well, this is where experiment tracking tools come to the rescue. A really popular one you'll see everywhere is the open source platform MLflow. Instead of having this tangled mess of scripts and spreadsheets, these tools just automatically log everything for you. We're talking the exact parameters you used, the performance metrics, the actual model files. It brings some serious order to that chaos and, best of all, makes your work reproducible and super easy to compare. And that leads us right into model versioning. You know how you version your code with Git? Well, you've got to do the same thing for your models. It creates this crystal clear audit trail so you can trace any model all the way back to the exact code, the exact data, and the exact parameters that created it. This is an absolute non-negotiable for debugging or, rolling back a deployment that's gone sideways. Now, a model registry takes that versioning idea and builds on top of it. Think of it like a centralized hub, a command center for managing all your models. It provides the governance you need to promote them through different stages, from experimental to staging for testing, and then finally, the big one, to production for release. So, to be super clear, what's the real difference here? Well, versioning is all about tracking the history of your models, the who, what, when. The registry, on the other hand, is about managing their journey to deployment. It's kind of like the difference between a library that just holds all the books ever written versus a curated museum exhibit that tells a specific story. Okay, so we've got a reproducible, versioned model ready to go. Awesome. Now it's time to build the assembly line that's going to turn it into a real product, one that we can ship reliably and at scale. And this, my friends, is where automation really takes center stage. And the first tool on that assembly line? Docker. Honestly, it's a total game changer. It basically packages up your model, its code, all its dependencies, everything into this one self-contained little box called a container. This finally solves that age-old developer nightmare, but it works on my machine. With a standard tool like Docker, it just works, everywhere, identically. And once you've got your model nicely packed in a container, something like Kubernetes becomes your air traffic controller. Let's say you get a sudden spike in users. No problem. Kubernetes, which is pretty much the industry standard for this stuff, will automatically scale up your deployment. It can go from just a few model replicas to hundreds in a flash. And then, just as importantly, it scales back down when things get quiet again, saving you a ton of money. Now, in traditional software engineering, the automated deployment pipeline, what we call CI/CD, is a pretty well-trodden path, right? You commit your code, you run some tests, you build the thing, and you deploy it. Simple enough. But for machine learning, oh boy, that pipeline gets a major upgrade. It's not just about code anymore. You have to add these really critical steps like validating the incoming data, maybe retraining the model on the fly, and even pitting your new model against the current production champion before you even think about deploying it. It adds a whole new layer of complexity and automation. So our model is out there. It's deployed, mission accomplished, we can all go home, right? Ha ha ha, not even close. Now comes the hard part. Now it has to actually survive out there in the wild, where the only thing you can count on is change. And there are these two silent killers that can absolutely sabotage your model over time. First, you've got data drift. This is when the world your model sees starts to change. Imagine a self-driving car that was only trained in sunny California suddenly having to deal with a blizzard in Chicago. That's data drift. Then you have concept drift. This is when the actual rules of the game change. Think about a spam filter that's suddenly hit with a completely new type of phishing email it's never seen before. Both of these will just quietly, slowly eat away at your model's accuracy. So how do you protect your users from a bad model update? Well, you use something called a canary deployment. Instead of a big, risky, all-or-nothing release, you just roll out the new model to a tiny fraction of your users, maybe just 1%. Then you watch it like a hawk. You're monitoring everything, not just accuracy, but also things like latency and error rates. If it's looking good, you gradually open the floodgates. If not, you can pull it back immediately. This strategy is all about containing the blast radius if something goes wrong. And finally, you get to the ultimate proving ground, the A/B test. Because at this stage, we don't just want to know if the new model is technically more accurate. We need to know if it actually moves the needle on what really matters to the business. Are users clicking more? Are they more engaged? Is it actually driving revenue? Because let's be real, at the end of the day, offline accuracy is just a number. Real-world business impact? That's everything. Phew. So, after that whole journey, from the pristine, clean lab all the way to the chaotic wild of production, what's the core mindset? What's the big takeaway from all this MLOps stuff? Look, if you remember just one thing from all this, let it be this. MLOps begins and ends with versioning. You have to version your code with something like Git, version your data with tools like DVC, and version your models with a registry like MLflow. If you don't do that, reproducibility is just a fantasy, and your entire MLOps practice is basically built on a foundation of sand. And that leads us to our final and maybe the most important question of all. Look, you've successfully built, deployed, and scaled your model. That's a huge achievement. But now, how do you know when it starts lying to you? Because the true test of MLOps is a marathon, not a sprint. It's all about building the systems that will alert you, without a doubt, the very moment your once trusted model starts to go wrong.